Hi everyone, this is a video lesson on the evolution of resistant bacteria. Now, as you probably know, bacteria are a type of microorganism. There's many different types, and some of them are capable of making us sick. Now, the good thing is we have these drugs called antibiotics, which I'm sure you're familiar with, which can kill bacteria and make us better. But the problem is, and the purpose of this video is to explain to you that some bacteria, like this little guy here, have evolved so that they are now resistant to antibiotics. So it doesn't matter what drugs you're throwing at these guys, they're able to survive, which is obviously no good for us, because we're going to be sick. So this video is going to look at the process that takes place and show you how bacteria can become resistant to antibiotics. Okay, so up here you'll see we have some normal bacterial cells. And let's say that these are a nasty type that actually make us sick. Now, what we know about bacteria is that they're really good at surviving and reproducing. Okay, so they replicate, and they replicate by that process of binary fission. And binary fission ensures that all of the daughter cells are genetically identical. So in a bacterial colony, you have lots of bacterial cells that are genetically identical. However, during the process of binary fission, sometimes there are some errors, and sometimes there are some bacterial cells that get produced that have random mutations. These random mutations give rise to variations, and those variations might make the bacteria resistant to antibiotics, and that can happen just through pure chance and coincidence. So when we get sick and we've got a bacterial infection, we might head over to the pharmacist and consult with our doctor, and they prescribe us with some antibiotics. We take the antibiotics, and those antibiotics work their magic, and their job is to kill bacterial cells. Now, normally in your body, when you weren't taking the antibiotics, these normal bacteria were the ones that had the advantage and they survived really well. The resistant ones had mutations, and it was actually a disadvantage to be a mutant when there's no antibiotic around. But because we've just taken this antibiotic and it's working its wonders, that's going to kill these normal bacteria, because that's what it's designed to do. So it's going to start wiping out these normal bacteria. And you're going to see now we're going to end up with a decreased ratio of normal bacteria to resistant bacteria. The antibiotics can't kill the resistant bacteria, it only kills the normal bacteria. Now that that's happened, what do you think these normal bacteria are going to do? These resistant bacteria, what do you think they're going to do? They're going to reproduce. So we're going to start to produce more and more of these resistant bacterial cells. Sure, there's still some normal that are around, but a reduced amount because we've just wiped them out with our antibiotics. And what you actually find happening is the more we're taking antibiotics, the more we're actually selecting for these resistant bacteria. So if we were to take another dose now of the antibiotic, here it is, okay, it does its job. Now, of course, these green bacteria, the normal ones, they're susceptible to that drug, so it's going to start working on those, and it's going to wipe those out. But of course, which ones are not going to be affected? It's these new mutants, the resistant bacteria, the ones that were at a disadvantage normally, but because we've taken the antibiotics, it's wiped out all of our normal bacteria, and it's only left us with resistant bacteria. Now, of course, I've really sped up the process. It doesn't happen that quickly. It happens over many generations and over lots and lots of exposure to antibiotics. But that's the process by which resistant bacteria become selected, and it's highly predominant in hospitals and places where you find lots and lots of antibiotic doses and medications. and it can be quite concerning and something that we need to stay on top of, and it's a reason for limiting our use of antibiotics. Right? You don't want to take antibiotics for viral infections because that won't do anything and they're not caused by bacteria. You only want to take antibiotics when it's absolutely necessary, because the more we use antibiotics, the more we're selecting these resistant bacteria. So just a final note for you, remember that the antibiotic does not cause the mutation. The antibiotic simply acts as a selecting agent. The mutations happen randomly and by chance during the process of binary fission. The antibiotic simply acts as a selecting agent. It's not causing the mutation, it's just selecting those resistant bacteria that had already occurred through chance. Alright, so that's the end of this video. Hopefully you've understood the concepts, and thanks very much for watching.